In this video we're going to look at basic trigonometry. We have a graphical calculator here called Desmos. Now we have a simulation in it, and we're going to build up this simulation so that you can work out exactly what basic trigonometry is all about. So we're going to be looking at the sine, the cosine and the tangent function. So let me just run this first of all just to show you what we have. So we have a generation of a sine function, which is in orange, and you can see the cosine function, which is in blue, and you can see the tangent, which is in black. And we've got a little point on a circle which just goes round about one full revolution back and forwards. So we're going to use this little simulation to work out exactly what trigonometry is, and you can see the values for the sine, the cosine and the tangent. So before we go on to the graphical calculator and looking at the simulation, we'll just have a little recap. We noted that if we had a triangle here and we called this length y and this length x and that angle theta, we could call that distance there r. Then we decided that we could say that the ratio of the y divided by x, which is the height of the mountain, divided by the distance away from the mountain, if you like, is given by the value tan theta. So remember, all tan says is the ratio of y to x at. That's all tan means. Now we could also write two other ratios. We could write the ratio of y upon r, and y upon r is given the name sine theta, and the ratio x upon r. Now the ratio x upon r is given the name cosine theta, and it's shortened to cos. Now look what happens if we decide we'll make r equal to 1. So we just say we make r the length 1. So if you make the length r 1, that means that y upon r equals sine theta. Well, that just simplifies to y equals sine theta because r equals 1. So we can just simply write in y equals sine theta. And the same with x. Instead of saying x upon 1, we could just say x equals cos theta. So it means this distance here can be given by cos theta, and this height here can be given by sine theta. Now we're going to be looking at terms of circles. We're looking at it and say, well, what's that got to do with a circle? Well, if we were to draw out a y and x axis and we were to draw a circle here, then if this radius here is always equal to 1, then if we were to draw out another triangle, say a triangle over here where we have a distance x and a distance y, well, that height there r is always equal to 1, and we could move this all the way round about, say, to another point here, and we would have a y and an x distance, and the length there would be r. So that would map out a locus of points all the way around in a circle. So that's how we get our circle. Now that's all there is to talk about here. We'll go on to the graphical calculator and we'll see how to build up the sine, the cosine and the tangent functions. So now we've looked at some of the basic trigonometry, we can go and we can build up the sine, the cosine and the tangent functions in the graphical calculator. So let's start off with drawing a circle. So we can draw a circle using the equation x squared plus y squared at 2 equals, and we'll make the radius of circle 1. Now we get a circle there because the radius there is going to be equal to 1, and it's saying that if we were to use the basic Pythagoras, if we were to say and perform Pythagoras, x squared plus y squared equals the radius squared, then we're doing that and we're keeping the radius always at 1. Okay, so when we do that, it's going to map out this circle. Now you can convince yourself of that by just simply clicking on a point. So take any point, there's a point there, and we can square 0.672, and then we can add on the square of 0.747 and we'll get 1, or we can pick another point down here and we can square those 2 points and we'll get 1. So every single point along that circle will be given by this the little equation here, x squared plus y squared equals 1. Okay, now what I want to do now is we want to put a little dot on the circle. We want the dot to go all the way around the circle. So we're going to do that, and the reason for that will become apparent as we work through it. So we can put a dot on that circle by adding just a label. Okay, so now that dot there, the position on the circle, we've seen from what we just did previously that the x distance can be written by with the as cos x1, and the y distance can be given by sin x1. So if we just write x is cos x1, and then the y will be sin x1, and we click on here, it will give us a little slider. There's a little slider there, and the little slider is going to go back and forward. You can see it going round in a circle. But now what we'll do is we'll adjust the actual limits. Okay, so we'll make the limits from 0, and here's a point here that I'll go on and explain in a different video, but we're going to give the end point as 2 times pi. You just write pi and it comes up with pi. Okay, so rather than writing the start point as 0 and the end point is 360 in degrees, we write the start point as 0 and end point is 2 pi because we're measuring this in something called radians, but we don't need to get into that right now. We'll get into that in either at the end here or in the next video. All we need to know is when we go from here up to 2 pi, this thing goes all the way around the circle once. Okay, so let's just get in, and we can actually press play and we can watch it going round and back. So there's a point going round the circle and then coming back. So you wonder why we're going to do that. Why do we do that? Well, you can kind of see, because if we take that point in the circle and we're interested in if we were to draw a line from this point to that point, so we'll draw the line in first from here to the circle. So we'll draw that in first. So in order to get that line from here up to there, we add in something called a table. So there's a table. Now the table just goes from one point there, which is the x and y, and you can put in a multiple of other points. So for example, if I want to look at that point there, the point there is 0, 0. So the origin is 0, x is 0 and y is 0. So we see a point just come in for the origin. We want to draw a line from that point there up to this point here. Now we know this point here, we've already worked it out. That point there is cos x1 sin x1. So we draw a line from there, cos x1 and sin x1. Now you look at that and saying, well, we've not actually got anything there. So you have to click on this little point here and just hold it down. And then if you drag that along, where it says line, you'll see we've drawn a line. So I've now got a line from that point to that point. So if I was to press play, you'll see we get this thing rotating round in a circle. And it'll just rotate round and then come back again. Now we're at a point where we can kind of see where we're going with this. If I was to fix this, say, at some point here, then we said before that the ratio of the y distance here, so that's the height of our mountain there, and that's the distance away from the base of the mountain from here to here, then we looked and we said, well, we were looking at the ratio of y upon x, and we called that our tan of this angle here, theta. But initially what we'll do is we'll look at the other two. Okay, we'll look at the ratio of y upon r, which is the sine of theta, and we'll look at the ratio x upon r, which is going to be cos of theta. So what we're going to do is we'll do the sine first. So we're going to drop a perpendicular from this point here down to this point here, and we're interested in looking at this height. Okay, so let's go ahead and we can do that just now. So let's say we're going to have to look at some sort of adding in a plus. Right, we're going to add in a table. So that table there is going to be given by, well, 2 points. So this point here is going to be the point in our circle, which is our cos x1 sin x1. So we put that in our circle. So that's going to be a cos x1 for the x point, and it's going to be sin x1 for the y point. So we've got this point here. Now the other point we're wanting is this point down here. So this point down here, well, the y height is going to be 0 because we're not going up any height, so the y height is going to be 0. So if we come in there, the y height is going to be 0. Now what about the x distance? Well, the x distance there is just our cos x1. So we'll have our cos x1, and again, if we want to see the actual line, we're going to have to click in here and drag it along to get the line, and we can just maybe put it in red. Okay, so we got that line there now. So if I was to press play on this, and let's have a see the thing moving about, and I'll move that up there because that's the one we're going to be pressing play on all the time. So if I press play on this, you can see the red value gets bigger. We watch at this point here. It gets bigger, then smaller, and then bigger, and then smaller, and then bigger, smaller, bigger, smaller. So that height there, if I pause it for a moment, that height there is given by our sine of this angle here. Okay, sine of the angle theta, because this length here is 1, so we said y upon r equals the sine of this angle. R is equal to 1, so we just say y equals the sine of this angle. So that means that we can draw out all these heights here, and from drawing out all these heights we can get the sine function. So what does that mean? We know what the height is. The height's this here, okay, but what's going to be along this axis? Well, along that axis is just your angle. Okay, so let's say for example we come down to the kind of the beginning. So we're down at this point here. So at that point there, what we would do is we would look at this angle here, so wherever that angle is, and we would come along the x distance, which is this angle, and then we would come up with this y distance, and then we could go and get another point. Say we get a point around here, so we would come along this angle here, so that's the angle, and we would come along a distance here which represents that angle, and then we would go up this height here, and we would continue doing this. So for example, if we went up to that point there, then we would come along the 90 degrees, and if we go along 90 degrees you see that height is equal to 1. Okay, and so let's continue and we'll do that. We'll get this drawn out. Okay, so we want to draw in a sine function, and the sine function is going to come up and along here. So how are we going to get the sine function? Well, a nice neat way of doing it is you could say f of x equals sine x. So there we go, we've got a sine function, but we want it to actually change, or actually we wanted the sine function to appear as we move this round about, so we can equate the position here with the actual position in the circle with the actual value for the sine function. So we can do that, and there's a neat little way there. We can put in these curly brackets, right, and inside the curly brackets we can put in limits. So we can say what we want to do is we want to make the value x, and it's got to be greater than or equal to, now it's going to be greater than or equal to 0, so the 0 degrees, okay, and it's got to be less than or equal to, well, less than or equal to, well, the value of x1, okay, because that the x1 just gives us the actual angle, okay, so we say x1. So now we've got a neat way of producing this sine function. So watch it happening. There's this, and I'll actually change this here, so it's maybe in orange, and it's I'll make it this like a kind of dotted. Okay, so now as we increase the angle x, you can see that the sine function is now starting to appear. So for example, if when we get the round to 90 degrees, so whenever the black line gets to the top, you see we'll get round to almost 90 degrees, then you can see that at almost 90 degrees, that's this big angle here, then the red line there, which is a sine value, is almost equal to 1. It's almost at height 1. You can see over here it's almost at height 1, and this point here is our 90 degrees. Now I have said before that I've actually done it in radians, so if I was to go in here, I could actually go in here and change it to degrees. If I went in and changed it to degrees, watch what happens. So now we're in degrees, okay? So it means that between here and all the way around the circle once is going to be 360 degrees. So if I zoom, I'd have to zoom all the way out like this and look at the scale. I'd have to zoom all the way out in order to get 360 degrees, and the whole thing disappears. So the scale is rubbish. So if I wanted to get it into a nice kind of scale that we can actually look at, I'd have to change it into this radians, and then that's us go back to a nice scale. So that's one of the reasons why we're going to be using radians here. It scales things up, but that's not the only reason, but we'll get into those other reasons in some other videos. Okay, so I can then produce this full sine function. You look at it, you can see that in this, that's the first quadrant here. In this, it's called the second quadrant, so it's the second 90-degree section. Second 90-degree section, you can see the sine starting to go down, and when you get into the third quadrant, you'll notice that the sine actually becomes negative. Okay, so that becomes negative, and you can see why that would become negative, because if you defining the value of sine as this distance here, well, that distance there is negative. Okay, it's not a positive value, it's a negative value, so that's why the value of sine is negative in this quadrant. And then when you come all the way round, you'll see you get to this point here, and at -1, the value of the sine is -1 here. Okay, so whenever I come round, all the way round here to the top there, I'll get all the way back to 0, and that's us got to the sine, and we've got to that point. Now that point there is equivalent to 360 degrees, but it's in radians, okay, and again we'll go over radians some other point. But that there is us built up the sine function. Okay, so all that is a table in effect. You could have a table of the ratios of this length here divided by that length there for this particular angle, and that's all this sine function shows. So I'll just let this run a couple of times so you can see it, and I'll also put a copy of this at the bottom so you can actually go and have a play with it on Desmos. Okay, so that's the sine function. So now we're going to look at the cosine function. So the cosine function we said was going to be the ratio of the x distance divided by the r distance. So if I drop that little perpendicular down there, it's going to be this distance here divided by that distance there. Okay, so what we're going to do then is we can look at this little length here. Okay, so we can look at that length there. Well, that length there is the same as for length from here back to here. Okay, so we're interested in the x distance to that point, okay, as the point maps around the circle. So if we draw a line from this point here up to this point here, how are we going to do that? So again, we're going to add in a table. So one end of the table is going to be the point on the circle, circumference of the circle, so that's going to be cos x1, and another point on that is going to be the sin x1. Okay, so that's us got this point here. Now what we're going to do is we're going to look for the other point here. So that other point here is this point. So that's going to be, well, you're going to go along 0 in the x direction, but you're going to go up the sin x1 in the y direction. Okay, so we can add that in here. So we're going to go 0 in the x direction, but we're going to go sin x1 in the y direction. So we'll end up with another line. So we'll drag that along to get the line, and again we'll put it in red and we'll make it dashed. Okay, so if I was to press play in this, I'll just pop this thing back up to the top. If I press play in that, you'll see that this red line here changes its size. Okay, so we're interested in the red line being 0 and then getting bigger and bigger and then smaller and then bigger. Okay, so that there is going to map out our cosine function. So what we'll do is, first of all, we're going to map out the cosine function, but we'll map it out not in this direction here, but first of all we'll map it out, we'll just map it out along in this direction here. Okay, so let's go ahead and do that just now. Now again, we're going to use the same process we used and using the sine function. So what we want to do is we want to draw the cosine function out down this way. Okay, now to get the cosine function, but we want to do it in terms of the y-axis, so you could say, rather than say f of x, we could say f of y equals, and it's going to be cos of x1. Okay, so that there is going to give us our cosine function, which is not quite right yet, is it? So f of y equals cos of yes, it's going to be cos of x. Okay, so that should, f of y equals cos of y, that's it, sorry. So we've got f of y equals cos of y, so that's the cosine function. Okay, but again, we don't want the cosine function starting, we're only starting at 0 and finishing it at 2 pi, so again we can just copy this, what we had above, we'll copy that again, Control C, and we'll go Control V. So we want it to start at 0, but we want it to finish in x1, but it's not actually x1 because it's actually going to be negative, isn't it? So we're going to through it in the negative direction, so it's going to be, we'll get there, minus y. So if I make that minus y, then we should now have, there we go, got there eventually. Okay, so we can see then that what's happening here, if I was to go back to 0 degrees, then what we're interested in is the x distance. Okay, so that's that distance along here. So that's the height there. So we start off at, the x distance is actually equal to 1. So we start off at that point as 1. And then as we move up, we can see the x distance getting smaller and smaller. Okay, so it's getting smaller and smaller until eventually you get to the point up there, which is almost equal to 90 degrees. So that's a 90 degree point here. And you can see the x height there is almost 0. Okay, so at that point there it goes to 0, and then it starts going to the value of negative, so x becomes negative, and that's a negative value here. And you'll see that there, then if I zoom out, will map out what we call the cosine function. So I'll let that press play, and you can see that mapping out the cosine function. Okay, so that there is our cosine function. I'll just let it run that once more so you can see it fully. Okay, so now we've got our cosine function, and we've also got our sine function. We can press play and we can open up and we'll let both of them appear. Okay, so if we pick both of them appearing, let's have a look and see. We'll turn both of them on. We'll turn that one on, and we press play there. Let's see if that's ever on. That's on, that's on, and we'll turn that on as well. Okay, so that's us now generated a cosine function here and a sine function here. But what we'll generally do is we'll take the cosine function and we'll just draw on the same axis as the sine function. Okay, so we'll actually just draw on along this axis as opposed to down this axis here. Okay, so let's just go ahead and we'll do that now. So we'll take that f of y off and we'll put another function in. We'll just call it, we'll take a copy of that and we'll change the y's for the x's. In fact, we can take a copy of this one here. We'll Control C and Control V. So we've got a copy of this here, and we're going to change that, and we want to make it the cosine function as opposed to the sine function. Okay, so that's the cosine function there. Now, if I press play in this now, and I'll change it so that again it looks similar. Okay, let's have a look and see. Okay, we'll change it so it is a blue colour, and we'll make it dotted. And then whenever I press play in that, we're going to have the sine and the cosine function appearing on the same axis. Okay, so there you go. The orange one is the sine function, and the blue one is the cosine function. So that's us generated those two functions. And remember, don't get lost in this. Remember, all this is telling us is that the height of this sine function is just the ratio of this height here to this height here for each and every individual angle. And the cosine function is the ratio of this height here to this height here, okay, for every single angle. Okay, now the only other thing that we need to do now is introduce the idea of the tangent. Now the tangent, remember, was the ratio of the y height divided by the x height. Okay, so let's go ahead and we'll just put in the tangent. So the tangent here is the same as what we've got here, only it's a tan, so we can copy that, Control C, Control V, and we'll just change that to tan. That's the tan function, and we can make this, and we'll turn it and make it black. Okay, like this. Now, if I press play, we'll see the sine and the cosine and the tangent all appearing. So there's the tangent function appearing in black, and you can see why the tangent function is different. The tangent function goes off to infinity, and you can see why that is the case, because if I was to bring this just round to just about that point there, so the tan function is going to be that height there divided by the little x distance. Well, the x distance is extremely small, so you're dividing a number here by a very, very small number. So if you divide one number by a very small number, you get a very, very big number. And whenever that goes to exactly 90 degrees, so when it gets round to that point there at 90 degrees, then the x distance is 0. So you're dividing a number by 0. So when you divide a number by 0, that's at 90 degrees. The tan of that is going to be infinity. Okay, so it's just going to be y upon 0, which is infinite. Okay, and you can see that the tan function is different from the sine and cosine as well, because the tan function repeats every 180 degrees. So we get to that point there. Okay, so that there, the sine and the cosine, well, they're only halfway through the revolution and they haven't started repeating yet, but the tangent function has gone up and down, and it's at that point there, which is 180 degrees, that the tangent function is going to start repeating. So that's the repetition. So when we get to the very end, you'll see that at 360 degrees, the sine function has got back to the beginning, the cosine function's got back to the beginning, but the tangent function's actually gone through once, twice, it's actually repeated twice. So the period, we can say the period of the tangent is 180 degrees, but the period of the sine and cosine is 360 degrees. So that's us for this video. We'll go on in the next video and we'll look at a few other parts of basic trigonometry. The other video shouldn't be any longer, maybe 10 minutes I think. Okay, thank you and goodbye.